Good afternoon. My name is Candace and I'm an event manager. On behalf of the staff at Town Hall Seattle and our friends at Elliott Bay Book Company, it's my pleasure to welcome you to our presentation with David Bainbridge. His new book, Paleontology and Illustrated History, is the subject of today's presentation. As we get underway, I would like to acknowledge that our institution stands on the unceded traditional territory of the Coast Salish people, particularly the Duwamish. We thank them for our continued use of the natural resources of their ancestral homeland. We're so glad to have you join us today. The presentation will run about 60 minutes, including Q&A. To submit your questions for the Q&A portion, please enter meet.ps/Bainbridge or scan the QR code right now on your screen with your smartphone. We'll drop this link in the chat as well, and you can submit a question at any time. We'll try to get to as many questions as possible, and you can help us by keeping your own questions concise. Also, a reminder that if you'd like to view the program with closed captions, you can click the CC button in the bottom right corner of the video player. Town Hall is adding new events and podcasts every day. This Monday, we're re-releasing a new episode of our In the Moment podcast with physicists Lori Winkless and Steve Scher discussing the sticky secret science of surfaces. And in April, renowned primatologist Frans de Waal shares what we can learn about gender from our closest ape relatives, chimpanzees, and bonobos. Visit our website to join our email list and get the latest updates as events are added throughout the season. Town Hall's work is made possible through your support and the support of our sponsors. As part of our Arno G. Matulski Science series, this event is supported by Microsoft. Town Hall is also a member-supported organization, so I want to thank all the members watching today. If you share in Town Hall's goal of a community energized and empowered by considering questions of civics, science, and culture, please consider supporting us by becoming a member. You'll find membership information on our website. And lastly, you'll want to dig into today's topic by purchasing a copy of the author's book. Use the link in the chat below, and you can get a copy through Elliott Bay Book Company. David Bainbridge is a comparative anatomist in the Department of Physiology, Development, and Neuroscience at the University of Cambridge, and a fellow of St. Catherine's College. His many books include How Zoologists Organize Things, The Art of Classification, Stripped Bare, The Art of Animal Anatomy, and Middle Age, A Natural History. Please join me in welcoming David Bainbridge.
Thank you very much. Hello, everybody. I'm just going to quickly share some pictures with you. It's lovely to be with you all this evening. This should appear within a few seconds in full screen form. If you're unfortunate, you may still have a little picture of me up in the top corner as well. Why is there a picture of me cuddling a kitten? Well, this is because I have to be upfront right at the beginning and say that I'm not a paleontologist. As with many of the things I write books about, it's not actually my day job. I did do a paleontology degree, as we'll see, but I'm really a veterinarian. I trained as a veterinarian at Cambridge, and that was really one of the things that got me into all of this. I'm a vet. My day job really is teaching anatomy and reproductive biology to veterinary students and natural scientists at Cambridge University. I suppose if I'm anything, I'm kind of a reproductive biologist, really. But for the last 20 years or so, I've also been a author of popular science books. And one of the things I learned very early on when I was writing popular science books is that whenever I was writing about things that I actually knew something about, my editors always didn't like those bits. They always said, "Oh no, this is a bit not good." And then when I was writing more as a science journalist, those were the bits they liked. So that kind of guided the direction of my writing career. And I was very excited. I think this is something like my 9th book, when I was eventually, after 2 decades, asked to write a book about paleontology, which really is every nerdy kid's dream. I'd been waiting for this opportunity, and then eventually it came. One of the reasons I like writing popular science is that, unlike when you're writing science, It's up to you what you write about. If there are things that interest you, then you can write about them. And if there are things that you think are boring, you can assume that other people will think they're boring, and you don't write about them. You can be wonderfully selective. And so that's really what this book ended up being. It was a personal view of the things in paleontology that interested me, with the hope that they would also be the things that interested other people as well. So in any book that's 260 or so pages long about a whole discipline, it is, of course, necessarily selective, but it's also, even more than selective, it's skewed towards my own personal preferences. So I thought I'd just start briefly by saying what influenced me, why I became so interested in paleontology over the course of my life, many decades as it is now. And there's a few things that sort of frame my interest in the fossil world. The first of these is the country that I was brought up in and still live in, which is the United Kingdom. Now, we are extremely lucky in the United Kingdom, and I think the reason that so much early geology happened here is that we just happen to live in a country which has pretty much every age of rock you can possibly imagine, and also laid out very neatly in diagonal bands running from southwest to northeast. So the map on the left-hand side is really the first small-scale geological map ever produced, which is the whole of England, Wales, and a little bit of Scotland by a very important man called William Smith. And you can see it actually doesn't differ very much from one created for Wikipedia fairly recently on the right. I moved house about 3 months ago, and I moved from the east red dot, which sits on some of the youngest and most boring rocks in the world, to the dot on the west. I've now moved to Wales from Suffolk. And it's not the oldest rocks in the world, but it's some of the oldest rocks in the UK. The oldest rocks in the UK are probably actually up in Scotland, because obviously you can't get more northwest than Scotland. So you just are aware of this range of ages of the earth around you in this country, ranging from very boring and very recent around London to incredibly ancient up off the coast of Scotland. Weirdly, my daughter's just returned. She's studying geology at university and has just returned from a field trip to one of those red islands hanging off the western coast of Scotland. She returned yesterday. So I do think geologically, I'm mainly saying this partly to irritate Americans, I do think the UK is the most interesting geological country in the world, or certainly within a small space. It's the most interesting geological country in the world. Another thing that greatly interested me was I was always that kid who, whenever it was time to arrange my birthday trip, when I was probably from about 5 years old onwards, I always wanted to go to the Natural History Museum in London, which is one of the world's great natural history museums. I was too young then to realise that actually lots of the dinosaurs were plaster casts of originals, which actually sit in American natural history museums. But we didn't like to talk about that. And I loved wandering around these places, and obviously I like the dinosaurs because every kid likes dinosaurs. But there was a particular hall there which was full of fossil fish, and they just looked, to me, those are my favourite because they just looked so ancient. Even compared to the dinosaurs, they looked like things that had been run over by a truck several times, you know, unfathomably many eons ago. So I always loved those. And also loved the various marine reptile fossils which are in the hall next to those. And at the time, I don't think I really realized that it was the discovery of these marine reptiles in Europe, but especially on the south coast of England, which in a way did more than anything else to really kickstart the science of paleontology, which really started pretty much exactly 200 years ago. So I always think of it as being, well, quite a new science, really. When you work at Cambridge University, 200 years is recent, really. I was lucky enough to study to become a vet, trained to become a vet at Cambridge University. But one of the good things about studying at Cambridge is that if you are a veterinary student or a medical student, in your third year, you can study for a Cambridge degree in any subject. And I picked effectively paleontology. So although I'm not a paleontologist, I did do a paleontology degree. And you're surrounded by so many influences when you're studying science at Cambridge. Obviously, Charles Darwin was a student at Cambridge. He was a theology student, I have to say, which didn't go very well, really. But his influence is all around you. But also, the year that I was studying paleontology at Cambridge, one of our lecturers, Jenny Clack, who unfortunately is no longer with us, she had just returned from northern Greenland, where she dug up these, again, amazingly archaic looking creatures, which she'd already named a Acanthostiga, which was to prove to be one of the key fossils linking land-living vertebrates with our fishy ancestors. And it was just so exciting to be working in that department, just doing my degree in the year when she literally just transported the fossils of Acanthostiga back from some barren cliffside in Greenland. So that was a big influence on me as well. The fourth influence that skews my interest in paleontology really is I love the history of science and seeing how, in a way, like most scientists, once something's worked out and understood, we lose interest in it. What's really fascinating is the process that people go through in trying to work out how something works. So this is a one of the possibly the most ancient representations of a fossil. This is it's called the Trojan whale, but we think that it was thought to be a monster, some sort of sea monster, when it was almost certainly, in fact, a fossil. There were lots of fossils around the Mediterranean, and in the ancient world, they were very aware that these things were there, although, of course, they interpreted them in different ways from us. For example, they found small fossils of pygmy elephant species on the Greek islands. They knew you could find shells, fossil shells, unfortunately didn't know what to call them. They knew you could find shells right at the top of mountains all around the Mediterranean. The ancient Greeks thought about this a great deal. The other thing is on some of the trade routes leading from the European world out towards East Asia. Along those trade routes, the cliffs would have fairly obvious relics of animals in the cliffs, visible in the rock. And so these things are all known to be there, and the various theories were developed for what these things actually were. Much of this, it came in a way, it's really sort of flowering of thinking in the Islamic world, which really started to clarify lots of this. It was Islamic thinkers who first really started to think of fossils as being not only dead animals, but animals that were extinct, animals that were no longer around in that form. They thought about what processes it must take for a dead animal to be turned into a fossil. They talked about sort of petrifying factors and things like that. As you may know, some Islamic thinkers came up with ideas which are very close to the idea of natural selection, more than 700 years before Darwin and Wallace. Leonardo also wrote about his thoughts about fossils. Many people at that time in Europe thought that rocks just spontaneously produced animal remains from nothing. But he thought this was a load of rubbish. He thought these were animals that had very much been alive at some point. And he started to think about, he suggested that the sort of layers that you could see in rock were actually the outcome of a process of layering on multiple layers. He didn't call them sediments, of course, but he started to think about the idea of sedimentation. Another famous person in this story is he's not called Steiner, he's actually called Niels Stensen. This was at a time when lots of people Latinized their names. He was Danish, although he actually worked in the Netherlands for much of his life. This picture is probably the most famous picture that's associated with him. This is actually the head of a white shark that had been sent to him to examine. He'd already been interested in the similarities between living sharks and also these funny little things that people have been finding in the rocks and not knowing what they were. He was the first person to suggest that these were the teeth of fossil sharks. But he went much further than this. He thought a great deal about why you would actually get solid animal parts lodged in solid rock, and also thought about how the surface of the Earth had changed over the centuries. Because one of the things you realize when you start looking at the early history of paleontology is it wasn't really a biological science. Paleontology really emerged from geology, which again is actually a remarkably young science, really. It's only a decade or two older than paleontology. One of the most famous and most charming instance in early paleontology was a publication in the 17th century of the picture of this rather strange fossil. We now know this to be the bottom end of a thigh bone of a dinosaur called Megasaurus. It was identified as coming from an ancient creature, as being a sort of vestige of an ancient creature. But unfortunately, it was misidentified, and so it was actually called Scrotum humanum for quite a long time. Now, there's a problem with this, is because once a fossil has been named, it's been given an accepted binomial Latin name, that name should not ever really change. And you can see why that would be the case. You wouldn't really want names changing over decades because it would just be confusing. And Megalosaurus is obviously a real dinosaur, because this is its thigh bone. So there was a very real risk at one point that Megalosaurus would actually not be called Megalosaurus, and it would have to revert to its original name as Scrotum humanum. But I'm pleased to say that for various reasons they made an exception in this case, and did not expect this creature to go by this name once this fossil had been properly identified. So that was the 17th century. Obviously, there was a great deal of thinking going on in the 17th century with the Enlightenment. This is a table which I have to include, really, because obviously paleontology has sort of co-evolved with ideas of evolution and eventually natural selection. But preceding the ideas of evolution really came just ideas about animal classification, and thinking about animals in groups and subgroups, and the idea of a species as well. And the reason I have to put this picture up is John Ray, who I think is the person who came up with the idea, the concept of the animal species and how they could be classified into groups like this. John Ray actually worked at my college in Cambridge, St Catherine's College. So I have to mention how it's kind of in my contract that he has to be mentioned. But he was really the start of something which became obviously the whole science of taxonomy, which of course is intermingled with evolutionary biology and paleontology as well. This may look very Anglo-centric or Britain-centric, but as I've said, because of the geography of this country, the geology of this country, parts of this story are, but don't worry, it soon moves off to other parts of the world. Now, because Britain really went through the Industrial Revolution before any other country, that meant that people were interested in things like mining and canals and road building and building foundations for large buildings. And so they became interested in the Earth, in Earth science, in geology. And that's the other reason why quite a lot of the early part of the story takes place in this country. And this is an early diagram showing how, although layers of rock may be laid down over long periods of time, you get these weird discontinuities between them, where you have rocks running in one direction and then a sort of abruption, and then rocks running in another direction. So this sort of fed in to what was to become quite a lively debate about how the Earth's formed, how the landscape is formed. Does it form very gradually, as the neat little layers would suggest, or does it form abruptly, as in sort of catastrophic events, as the transition here, for example, would suggest? So this was sort of, I think, almost the prehistory of paleontology. This is pre-paleontology, when people were just beginning to think about how the landscape is formed and the place of fossils within it. And as with so many things, I think you can pretty much put a fairly clear era when paleontology started in the early 19th century. This was when people like Baron Cuvier were publishing pictures such as this. This is in a book called Le Règne Animal, and I was very pleased that one of the weird things that happens when you look at my university is when I first moved into my departmental office about 19 years ago, there was just a first edition of this book sitting on the shelves. I thought, okay, we'll have a look at that. And Cuvier was a very special person, although many people didn't agree with him about his ideas of how the Earth formed and how the landscape formed. He's very clearly one of the start points of thinking about how these animals locked within the rocks could be compared to and possibly related to animals that are still alive today. And I think it was this sort of thinking that really established paleontology as a proper science. It grew out almost immediately. Geology had started, paleontology grew out of it. And so the rocks and the animals that are found in them became inextricably linked. And this is 1816 and 1817, so the same date essentially as the previous picture. This was an Englishman called William Smith. He was a surveyor. He was involved in things like planning out the canals of the British Industrial Revolution. And he produced not only the geological map that I showed you right at the beginning of this, but also he showed these equivalences. He went through the different ages of rocks, and he showed how each age of rock would have a distinctive set of fossils in it. And so you could tell the fossils from the age of the rock, but also you could tell the age of the rock by looking at the fossils. And so that's why paleontology and geology really became inseparable, because they were equivalents. You'd use the animals to determine the rock, and the rock to determine the animal. The other thing, of course, that paleontology needs, rather than just new ways of thinking, is it needed specimens. And again, for various reasons, some of the most important early specimens in paleontology were found in England. This is actually relates to a fossil hunter called Mary Anning. Had a film made about her in 2020, starring Kate Winslet, and she is famous because, I mean, this sort of goes back to the early ichthyosaurs that I used to see as fossils in the London Natural History Museum when I was a kid. She found many of those, and not only did she find many of those, she was much more than just a fossil hunter. She also did quite a lot of the characterization of what those fossils actually were. Unfortunately, she was working at a time when the ability of women to actually do the interpretation of the specimens was rather looked down on. And so we're not sure, because she was quite a self-deprecating person at times, but also just the evidence of exactly what she did with these fossils, bringing them to a wider attention of the world, has unfortunately, we think, just been lost. But she was certainly very important in driving paleontology, just as Cuvier was, because, of course, to do paleontology, you need the specimens in the first place. Unlike some sciences, you're limited by what you can find. And the way people think about the Earth and about animals changed incredibly dramatically over the course of maybe 40 to 50 years in the early 19th century. A few examples here. Charles Lyle, he was a geologist who, apart from being sort of the godfather of the world of natural selection, evolution, he was one of these people who fixed the idea of a very ancient age of the Earth in people's minds. For animal change, for evolution to take place, it seemed to need a lot of time. And according to the biblical narrative, it only had a few thousand years. That really did not seem long enough. And he was one of the people who established that change took place over long periods of time. The change was often gradual. And even if it was catastrophic, then it still occurred according to the same natural laws. The natural laws that guided this change did not change, themselves change over time. This funny looking graph on the right is from Lord Kelvin, and so from the name you might imagine it's something to do with temperature. He was one of the first people to really try and calculate how old the Earth was based on how long it would have taken to cool down. And he calculated that the Earth should be at least probably several million years old. There were certain things that he didn't know about, but his estimate was rather low. But it showed that the Earth was much longer than 6,000 or 8,000 years. It showed that there was time for evolution. Evolution is another concept which really got going in the early 19th century and came to fruition in the mid to late 19th century. There's time for evolution to occur. So the reason I've got a picture from a book by Alfred Russel Wallace is because although evolution, the process, had been known about since the early 19th century, the actual mechanism by which it occurs, now called natural selection, was not published until 1859, and it was co-published simultaneously by two people, Charles Darwin and Alfred Russel Wallace. And it's just sort of an accident of history that one of those two people is incredibly famous and the other one is less so. But it was a co-publication by two scientists working on opposite sides of the world that first put that idea into the public forum. So as I said, this may have seemed very Britain-centric so far, but things then change. And certainly if you're a dinosaur buff, actually Britain is not a very good place to look for dinosaurs. You can count the number of dinosaurs that we discovered in Britain on the fingers of one hand, probably not quite the fingers of one hand. The place where dinosaurs really took off and entered the public consciousness was in the United States. And this was, I mean, much of this, of course, is luck. It's just where the dinosaurs actually are. But also there were particular, very forceful, let's put it that way, individuals who carved a swathe across the new frontier out towards the west, Wyoming and Montana and Colorado, places where still new exciting fossil finds are being made every year. Edward Drinker Cope and Charles Marsh, who initially actually worked together, but very soon fell out with each other. And the acrimony that developed between them really lasted throughout their lives. So it's rather ironic that they're now always mentioned in the context of each other. It was actually called the Bone Wars. They went to various lengths to make sure that it was they who found the right fossils. They would buy people off, they would buy information, they would deliberately try and foil each other's fossil hunting plans. And yet it is they are the reason why it's the American Natural History Museums that have probably the best dinosaur fossil caches of all. Lots of the many sort of classic creatures that we now think of that you remember from dinosaur books from when you're a child. The dinosaurs that people know about, most of those were found during this tremendous flurry of fossil hunting in the late 19th century. And so many of these fossils were characterized and described and sometimes partly named after these two warring individuals. This is one, lilacs, perhaps not that famous, although it was very famous initially, from 1869, that rather dramatic curved claw, which has reappeared in various other animals and also various other media since then. We'll get onto that in a bit. The marvelous Stegosaurus, one of these animals where if you haven't seen enough evidence, you really would think somebody was making it up. Because I was writing a book which was supposed to be an illustrated history, sometimes I just went for the pictures that I thought were the most striking. I think this is possibly my favourite. This is my favourite dinosaur picture. Anyway, this is from a slightly obscure treatise from a series of paleontological journals of the Smithsonian Museum, most of which are text only. And there's this one that pops up, I can't remember which volume it is, which is full of these beautiful engravings of a Triceratops skull from various views. And so there are some of these pictures that I just thought, well, I don't know how important they are scientifically, but as I said, when you're writing a popular science book, if you like the look of something, then you just get to include it because you can. Pteranodon and the pterosaurs, I've already mentioned those again in a bit. Another character who appeared was a chap called Barnum Brown, who was named after the circus promoter, who again, and sort of linked with the American Museum of Natural History in New York. He's another reason why that museum is full of amazing fossils. Again, the fossils from which the plaster casts that I saw in London as a child were largely made. But then, of course, there are other areas in the United States and North America with important paleontological history. This is actually a photo I took in the museum at the La Brea tar pits. Obviously, that's a very unusual, I suppose it's a sort of fossil bed, but it's very unusual. These are much more recent animals than any of the others that I've been talking about so far. So one has to be admitted that the Western United States is unusually blessed with exciting and sometimes visually attractive fossils. And if you nudge just north over the border, you come to possibly the most important fossil bed in the world. Some people might argue with me about that. But this is a fossil from Birches Shale, which is a fossil bed in Western Canada, characterized largely by scientists from the Smithsonian Museum of Natural History, and then subsequently recharacterized by scientists from Cambridge University. And there's tremendous argument about who got things right, who got things wrong. But I won't get into that now. The reason I have this particular fossil here, I have to say there are much more dramatic fossils discovered in the Birches Shales, but there's a particular reason why I chose this one. Now, the reason the Birches Shale is important is because they were fossils that were laid down at the time, it's called the Cambrian explosion, when multicellular animals, complex animals, were really experimenting with new body shapes, new forms, and they were just thinking about evolving into the main different types of animals that we see today, like vertebrates and arthropods and mollusks and things like that. But they hadn't quite made their mind up. So it's a time of sort of tremendous evolutionary experimentation. And so some of them are very amazing to look at. The reason I picked this one, Pikaia, is because this is one that has many characteristics that make people wonder if this is related to vertebrates, whether this is sort of the precursor or a relative of the earliest precursors of vertebrates. You can see the sort of serrated muscle that run along this slightly fish-shaped organism, just like the ridges of muscle run along the body of, say, a salmon or something like that. So yes, it is partly luck. What you get the fossils which nature has dealt you. Then Another thing which I sort of enjoyed mapping in this book was just thinking about how we sort of have this classical world of dinosaurs and fossils up to about the Birches Shales, and then that really marks the start of a time when we started thinking very differently about the ancient world, and people became much more flexible and way more scientifically modern in their thinking. This is a diagram of a book by from a book by Alfred Wegener, where he started talking about continental drift, about how continents have shifted over the surface of the Earth over its very long history, an idea which we now take completely for granted, but that doesn't make it any less surprising how long we went without knowing that this is what was happening. They didn't know the mechanism. Plate tectonics didn't really pop up as a concept until about the 1960s. But the idea that the continents moved over the world, of course, carrying their rafts of animals with them, and thus accumulating fossils, paleontological specimens, differently according to their sort of history of their migration across the surface of the globe. This idea really started this early on. Lots of people didn't believe Wegener when this first came out. People were starting to standardize their ideas of, I mean, I'm biased because I'm a vertebrate paleontology. Other types of paleontology are available, but I've always been particularly fascinated by this one group of animals, of which, of course, we are a member. And around the sort of 1930s or so, people had really nailed down the sort of classical pre-genetic idea of what the vertebrate body plan was and how it might have come into existence. Although I have to say, of course, this is a story that still goes on in many paleontology, but also many developmental biology labs all around the world. So it's a clear indication of how paleontology links up to morphology and embryology and all these other disciplines as well. People started to challenge the way we thought about how animals live. This is one of my favorite paleontological diagrams. This is from the 1960s. This is where I think the velociraptors of Jurassic Park took their origins. This is from a paper about quite a small creature, much smaller than the raptors in Jurassic Park, called Dynamicus. And this one image, I think, was the image that really fixed in people's mind the idea that dinosaurs didn't have to be dull, cold, lumbering, rather stupid creatures, just the way that this animal had been reconstructed by Bob Back and John Ostrom. I think just looking at it, it just makes you think that dinosaurs did not have to be that way. I'm going to flick through a few because, as usual, first few times I will talk, I always get the timing wrong. We started to think about the mechanics of animals. I still don't really understand why pterosaurs don't snap. I can see how they could fly once they were up in the air, but I don't see why they didn't smash themselves to pieces when they tried to take off or tried to land. We started to realize that those who thought that catastrophes were an important part of evolution probably were right. But this is some data. This is the picture on the right. There's a map of part of Mexico where it's thought that the asteroid that struck the Earth and set off this chain of events that led to the extinction of the non-avian dinosaurs, thought that it hit just off what is now the coast of this part of Mexico. And this is a map of sinkholes, and there's a ring around where they think that impact occurred. The one on the left is this rather weird spike of abundance of a particular element in the Earth's crust around that time, the so-called iridium anomaly, which is thought to have been related to that event. So the way we thought about paleontology, the way we thought about evolution changed, and the way animals were represented artistically gradually changed as well. Paleontology, because you can't see the animals, of course, you can really change the way people think by just presenting them in a particular way. You can have your little reptile with its tail sort of almost dipping into the water, sort of signing how animals are now on land for good. And just the idea, for example, in this other picture on the right, the idea that Tyrannosaurus has had to sleep sometime. People sort of constantly thinking of new and interesting ways to represent animals, and some of these have been sort of people criticised. For example, the picture of Megalosaurus, or Scrotum humanum, as perhaps it should have been called, as not being very representative. But the way it's poised, the way it's drawn, did it influence? And whenever a picture like this is produced, it influences the way people think about the science underlying this. And this isn't all about still images. One of the things I really wanted to talk about in my books, and I'm very pleased I got a chance to do so. Of course, one of the most important art forms in which dinosaurs are presented is, I don't think it's any coincidence that two of the best movies ever made have dinosaurs in them. 60 years apart, although it's depressing to say that Jurassic Park is now nearly 30 years old. These are two films. I mean, of course, I only remember when the second of these two films came out. It's one of the films that I remember going to see it in a cinema with lots of people and everybody being amazed because they had never seen anything like this before. And I can only imagine that the first King Kong film was like that as well. If you haven't seen the first King Kong film, or you haven't seen it for a long time, I strongly advise you to watch it again. It's certainly here, it's very easy to buy for very little money on DVD. You can actually get it on a physical DVD, which I know people don't do very much anymore. But it is worth watching. It's an amazingly modern and striking film from 1933. It's quite shocking and disturbing in some ways, and the ferocity of some of it is really, you didn't think that cinema used to be like that, but you watch this very mainstream film and clearly it did. And of course, being me, I think the fight with the dinosaurs, or the fight of the dinosaurs, is the most exciting part of that film. The reason I wanted to talk about these films is really because I think it just shows how paleontology and what it's shown us has permeated into popular culture. The other thing I did talk about in my book is I've looked at the last 30 years as well, because as more and more information has arisen, we've needed more and more visual ways to present it, and that's big data is very hard to present, but it normally leads to lots of very visually striking and also artistically interesting ways of showing the fossil finds of the last 30 years or so. And so it's one of these things, as with so many areas of science, but maybe you might not have expected it in paleontology quite so much, is that I've been lucky to live through a series of decades where, when I was a child, there were various things that people just assumed they would never ever know about the ancient world and the animals that lived in it. And yet now, and I'm not that old yet, but 5 decades later, we do know many of those things. And it just shows how, as soon as a scientist says, oh, we'll never know so and so, you can be pretty sure that within the next few decades, or sometimes the next decade, somebody will prove them wrong. Just by thinking that something is impossible, you're almost guaranteeing that it is going to be done by somebody somewhere in the world fairly soon. Anyway, with that, I hope I've just given you an idea of sort of why I loved writing this book so much. Yes, I welcome your questions.
Thanks so much. Yeah, we do have a good number of questions here. So the first one, can paleontology tell us how far back in the past we could go before we could breathe the atmosphere?
It depends what you mean we and what you mean by breathe. I mean, organisms, of course, have been interacting with the atmosphere ever since there's been organisms, which seems to be the further back you go, the further back you seem to find organisms. There doesn't seem to be the Earth, although the Earth is probably about 4.6 billion years old, the age of the oldest organisms gradually appears to be creeping back that far. We do, I mean, partly because of geology, partly because of paleontology, we are getting an idea of when the main sort of oxygenation events occurred. The Earth's atmosphere is very oxygen poor. I mean, most planetary atmospheres are oxygen poor because oxygen is very reactive, and so as soon as it's produced, it's immediately bound into some other compound or into a rock. And the only reason that the Earth's atmosphere has oxygen is because plants and, well, the things that evolved into bits of plants, blue-green algae or cyanobacteria, produced oxygen. And so we can see the actual oxygenation events in the geological record as they occur. And having this incredibly reactive and potentially dangerous element in the atmosphere is thought to be the thing that really kick-started complex multicellular life, because complex multicellular animals need lots of energy. And one of the ways you can get lots of energy is to basically burn food using oxygen. You can live without it, but you can't get that much energy. So yeah, we know increasingly more about that process.
Let's see. With England being so rich in fossil findings, are there laws currently about digging when someone is about to break ground in England that hasn't been broken before?
They don't talk about fossils. They worry about archaeology a great deal. I mean, I have to say, I mean, the weird thing is, as I said, for spectacular fossils, Britain is actually quite fossil poor. We have lots of things like mollusk shells and ammonites and things like that, which you get anywhere else in the world. The striking thing about Britain really is the range of the ages of the rocks in such a small island. But there aren't that many, apart from your sort of the Jurassic marine reptiles, they're not actually that good for spectacular fossils. I'm not sure there are particular laws about it, whereas there are for archaeology. But I mean, the thing I'd be interested to know is what the laws are in places like the United States, where it's quite possible that people could be digging up fossils which could be worth millions of dollars if sold on the open market, and some of them are sold on the open market. So we don't have to, because we probably don't have any fossils that are that valuable.
Let's see. How much trouble did scientists in the, I don't know if it was, yeah, it was the 18th century. This is what they said. How much trouble did scientists in the 18th century get into with the church and their new theories of how old the Earth really was?
Yes, I mean, this is interesting because, I mean, you look at it, but I mean, the Enlightenment and the establishment of the Royal Society, and then the Victorian era as well. It was strange. I mean, the religion in the UK is kind of weird, but the Anglican Church, I mean, although in some ways it was quite a dominant force, it's got this weird ability to coexist with non-religious ideas, or sometimes even counter-religious ideas. I mean, I think that's probably, you know, so we have this rather strange thing where the church in this country is established, so our head of state, the Queen, is also the head of the church. And I think the only reason why this can still persist is because of this weird sort of, it's a strange sort of plastic nature of the Anglican Church. And so it is, and the other thing is lots of people who were involved with many of these finds were, you know, they were fully, you know, paid up Christians throughout their life. And they seem to, there seems to be this possibility of having this sort of continuing double thing about how you could sort of believe two things at the same time, which is a weird feature of, I don't know, I think it's a sort of British intellectual psyche, really. And I suppose a counterexample to that would be somewhere like France, where the whole French state is set up in a very secular, aggressively secular way. which also seems weird to people in Britain. With it, I don't know, with this weird, culturally, with this weird sort of, I don't know what's going on in this country as far as these things are concerned. We sort of just quite happily accept two contradictory points of view at the same time. That
They
seems to be
they
right.
maybe weren't trying to directly counter the church either. They weren't trying to be confrontational.
No, I think they probably weren't, and also, but I mean, some of them do individually write about their worries about these things. And like I say, Charles Darwin studied theology when he was at university and was expected to go on and become a clergyman, but obviously didn't. So I think individuals within themselves did face quite sort of dramatic internal turmoil as a result of all of this.
I think you did mention a little bit of this, but how much fake fossil findings happened in the past, or maybe still happens? Is it even possible for that to be a
Yeah,
problem?
I actually did. There was one picture that I didn't have a chance to show you, which was quite a recent sort of forensic analysis of a fossil called Archaeoraptor, which turned out to be made as a composite of multiple different, probably very important fossils that had been broken up and recombined into this new non-existent creature. So yes, it does happen. The most famous one in this country is, everyone here talks about it, sort of laughs at it. I don't know how well known it is around the world. It's this thing called Piltdown Man. This idea, and it was this fossil which was supposed to represent the sort of ancestral Englishman, and it's found in a sort of typical sort of English village. And it was even alleged that this human fossil had something that looked like a cricket bat with it. And it wasn't until a weird number of decades later that it was discovered that it was basically a fraud, a deliberate fraud. It was a skull of a known human fossil and a jaw of an existing primate. Of another existing primate. And so it should have been quite easy to debunk, but it didn't. So in this country, the Piltdown Man is the best known one. But no, they do crop up, and people do create fake fossils just the same way they make fake paintings.
I think we have at least one younger person watching tonight. We can't totally know for sure, but we are guessing. Why do you think so many kids get obsessed with dinosaurs? What's the draw?
Wow. I mean, I think it's the strangeness. I think it's the idea that these things actually walked around where we walk around, and yet they are so alien. Not so alien, but not so alien that you can't understand them. Alien enough that they're just gripping, and you just sort of think that they just look. I think it's partly because you see them originally as fossils, as originally as skeletons. You sort of think of them as having this very savage life that was very exciting and very adventurous. One of the things that I always find quite funny is that if I occasionally give talks at schools about, I just take along like skeletons and cats and fish and things like that. And whenever you show kids who are sort of 6 or 7 a skeleton of anything, they always go, "Is it a dinosaur?" And so I think it's this linking of skeletons and skulls and dinosaurs, because that's all we have left of them. I think bones in themselves are just things that fascinate kids as well.
Are there any known gaps or limits in the geologic record?
There's a whole science of studying the fossil record. So there's a fossil record. Geological record is quite complete over, if you look all around the world, fill in all the gaps from around the world. Geological record is quite complete back to really the time of the Birches Shales. The fossil record first of all, there can be gaps where there are periods of time when no fossils are laid down. But also there's just the whole question of why does some dead animals fossilize and others don't? It's so rare. It's definitely the weird exception that breaks the rule. So that for every fossil you find, there will be millions and millions of animals that are fossilized. So they're by definition they're a very unrepresentative sample. And so sometimes people find a place where there's just the left humerus, hundreds of left humeruses of one animal, and it's because there was something about the bend in the river that the bone that shape got stuck there and fossilized. And so there's the gaps which you talk about, and there's also the sheer unrepresentativeness of the record as well. And there's lots of weird things, like lots of human fossils don't have fingers and toes. And that's because big felines, if they find a dead person, the bit they often chew off and eat is the fingers and the toes, because they're the easiest bits to chew. So yeah, this is part of a very wide question about how representative the fossil record is, even where it exists. But certainly, I mean, the further you go back, yeah, there are big gaps that appear. And the one thing you can be sure is that you almost never got the actual ancestor of things. You've just got a relative of its ancestor, and its ancestor may never be found. It may never have fossilized at all.
I can imagine that is maybe frustrating to know. So I'll make this a final question, kind of related. What would you say is the future of paleontology?
The future of paleontology, I think, while obviously it's always tempting to look for things that will fill in the gaps in the fossil record, I think that certainly in the foreseeable future, quite a lot of paleontology will be based on applying new techniques to fossils we already have. So whether that's new medical diagnostic imaging that basically we can turn on the rocks and apply to fossils, or various other new scientific investigations of fossils we already have. I think this reliance on finding new fossils to discover new things, I think that's going to wane a little bit, because we'll find we can actually learn lots of new stuff by using the same fossils we already have and just applying the new techniques to them. That would be my guess, but we'll have to see.
Well, thank you so much for joining us today here and your evening there. It's been really interesting listening to you.
Thank you.
Really interesting images. I want to thank the audience also for joining us today. If you're interested in purchasing a copy of David's book, please use the link in the chat, and that'll take you right over to Elliott Bay. So best to you on the rest of your events, working with speaking about this book. I think you said this was your first one. Yeah, good luck with that, and hope to see you in person someday.